Solving multi-step equations. At the end of this video, you should be able to answer the question, how do I solve multi-step equations with variables on one side of the equal sign? Let's illustrate this process with an example. Keep in mind that all the things you've learned in the prior videos, such as your goal is to isolate the variable, that still applies, as well as the properties of equality, meaning whatever you do to one side of an equation, you must also do to the other side. So remember that your two sides are separated by the equal sign. If you look at the left, you see a set of parentheses. You want to get rid of that first. So think about the property that allows you to get rid of that, and hopefully you're thinking we need to distribute. So we take 4 times the quantity of x minus 3, which results in 4x minus 12 plus 2x equals 36. Next, you want to see if you have any like terms on just one side of the equal sign. And on the left, I spot a 4x and a plus 2x. So when I combine that, that results in 6x, recopy the minus 12, equals 36. Now this should look like a two-step equation that you're familiar with. To get rid of both the 6 and the minus 12, you want to undo your addition and subtraction first. So let's add 12 to both sides, which results in 6x equals 48. Finally, separate the 6 from the x by division. Use your fraction bar to show that you're dividing both sides by 6, and you get x equals 8. All right, this next one, let's just do one more quick problem, followed by how to do an algebraic check. So again, we start by distributing. So I'm going to do 3 times 2x, 6x, minus 21, recopy the minus 5x, equals 4. Next, you want to identify and then combine any like terms. 6x minus 5x would be 1x. Recopy the rest of the equation. And now I need to undo the minus 21, so I add 21 to both sides, which results in x equals 25. Now, it's always a good idea, especially on an assessment, or if you're unsure of a process, that you did the correct steps by doing an algebraic check, which means you're going to substitute. So if I recopy the original equation, and what I'm going to do is I'm going to plug in everywhere that there was an x, I'm going to replace that with what I think it equals. So I have 25 and 25. So on the left, I have 3 times the quantity of 2 times 25 minus 7. I've got to do what's in parentheses first. 2 times 25 is 50. Minus 7 would be 43. Minus 5 times 25, multiplication stronger than the subtraction, so that'll be 125 equals 4. Then 3 times 43 is 129. Minus 125, I'm checking, does that equal 4? And it does. So that tells me that x equals 25 is the correct solution. In example 3, I want to show you an alternate way rather than distributing. The tendency here is to distribute the 3/5, but if you do that, you're going to end up with more than one fraction, and typically students try to avoid fractions. The computations become a little easier. So an alternate way is the 3/5 is held by multiplication to the parentheses, so we could get rid of it by dividing. But remember, the definition of division says that you can multiply both sides by the reciprocal. So I'm going to multiply both sides by 5/3 rather than distributing. So on the left I have 3 factors, 5/3, 3/5, and then this whole quantity is a third factor. So I'm going to multiply the first two together first, which results in 1. And 1 times 2x minus 4 is just 2x minus 4. On the right, the 3 and the 18 will reduce, so I get 6 times 5 is 30. This is a much easier equation to solve. I'm going to undo my addition and subtraction to get 2x equals 34. Then I divide each side by 2, and I get 1x equals 17. Now, let's do a check once more just to make sure that we're getting the right answer. Checking if the left equals the right side. So I'm, again, substituting in the 17, and inside parentheses I have 2 times 17 would be 34 minus 4 would be 30. So I have 3/5 times 30. Does that equal 18? And it does. 18 equals 18, so I know that my solution is correct. The fourth problem is an example of an application. So it says, if the perimeter of the triangle is 24 feet, determine the length of AB. So perimeter is a key concept here. Let's think about what we know about perimeter. Perimeter is the distance around a geometric shape. So if I add all the side lengths, the first one's x plus 4, plus the second one, segment BC, is 4x, plus segment AC would be 10 times the quantity of x minus 1. That has to equal the perimeter, which I know is 24 feet. So now I just have a multi-step equation. I'm going to distribute to get rid of the first set of parentheses, which results in 10x minus 10 equals 24. Now I look for and combine my like terms. So I've got several sets of x's here, which results in 15x, and then I have some constants. The plus 4 and the minus 10 would be minus 6 equals 24. Now, isolate your variable by adding 6 to each side, which gives 15x equals 30. Then divide each side by 15, and you get x equals 2. Now that's just the value of x, but we are asked to find the measurement of side AB. So you're going to substitute to get that. X plus 4 is the side length, so you're just doing 2 plus 4, which would be 6, and the measurement here is measured in feet, so that side of the triangle is 6 feet long. The final one on your note page is very similar. It's a perimeter question, but it's talking about a rectangle. So my strategy is to first start by drawing a rectangle and filling in the information I know. It says the length of a rectangle is 2 less than twice its width. Less than and twice are keywords I know. And I don't know the width, so I'm going to call this side W, and the length is 2 less than twice the width. So twice the width is 2W, but 2 less than that would be minus 2. I also know that perimeter is equal to 2 times length plus 2 times width. Now I could just add up all 4 sides, but I'm going to show you using the distributive property here. So the perimeter is 26 equals 2 times what the length is, and I know the length is 2W minus 2, plus 2 times the width, and the width is just W in the picture. So I'm going to distribute and get 4W minus 4. We copy the plus 2W. Now I'm going to combine like terms to get 6W minus 4. And now I isolate my variable. I add 4 to each side, and I get 30 equals 6W. I'm going to divide each side by 6 to get W equals 5 feet for my width. So I have the width. I need the length. So I'm going to substitute again. The length was 2W minus 2 in the picture, so I'm plugging in 5 where the W was. 2 times 5 would be 10, minus 2 would be that the length is equal to 8 feet. So now I have the length and the width. Okay, you should now be able to answer the question, how do I solve equations with variables on one side of the equal sign?